Before going into the logic of hypothesis testing, let us make it clear what is a hypothesis. Very simple. A hypothesis is a statement or an assertion or a conjecture, the validity of which is sought to be tested. It is a statement about which one is not sure whether it is true or false. And so, a test for this is required. Suppose an economist is saying that the GDP of India has decreased by at least 5% during the last 3 months. Suppose on your asking whether he is sure, he replies that he is not sure. This is just what he feels. So far it is not known whether the statement is true or not. This statement remains a hypothesis. Once it is established that this statement is either true or false, it is no more a hypothesis. Similarly, if someone is saying that Americans on the average are taller than Indians, but he is not sure about it, it may be his hypothesis. So far, the validity of this statement is not established. Now, what do we mean by hypothesis testing? Hypothesis testing consists of taking either of two decisions: to reject the hypothesis or not to reject the hypothesis. Thus, the hypothesis testing is a two-way decision theory. We reject a hypothesis if it is found false after applying the test, and do not reject if there is no sufficient evidence against it. In testing of hypothesis, we always start with two hypotheses. One is null hypothesis and the other one is alternative hypothesis. What is a null hypothesis? Very simple definition. A hypothesis under test is known as a null hypothesis. The hypothesis that you are going to test is the null hypothesis, and it is usually denoted by H0. This null hypothesis would either be rejected or accepted. If it is accepted, then there is no problem. But what would happen if it is rejected? In other words, in this case, then what would be accepted? Rejection is a negative action. We must tell that if rejected, then what is accepted? In our natural practice also, we find that during some discussions among friends, having some hot arguments, when someone says that no, I do not agree with you, it is not true. What you are saying is not true. Other friends start asking that if it is not true, then you tell what is true. Same thing is in hypothesis testing. If you are rejecting a null hypothesis, if you are saying that it is not true, then you must tell then what is true. So, a hypothesis in favor of which a null hypothesis is rejected is known as an alternative hypothesis. It is usually denoted by H1. So, one is null hypothesis, the other one is alternative hypothesis. If null hypothesis is rejected, alternative hypothesis is accepted. We reject null hypothesis for accepting alternative hypothesis. The role of alternative hypothesis is very important, and its framing must be done very intelligently and carefully. I would give you some examples. Suppose that some botanist thinks that the average length of a leaf on a particular tree is, say, 3.4 centimeter. So his null hypothesis is, which is denoted by H naught, the mean length of a leaf on the particular tree is 3.4 centimeter. What would be the alternative hypothesis? The alternative hypothesis would be that the mean length of a leaf on that particular tree is not equal to 3.4 centimeter. Because as null hypothesis is rejected, alternative hypothesis is accepted. Only one of these two hypotheses would be true. The other one would be false. If we denote the mean length of a leaf on that particular tree by mu, In short, we can say that H naught is, null hypothesis is, mu equal to 3.4 centimeter. And the alternative hypothesis is mu not equal to 3.4 centimeter. Many of you might be thinking that who doesn't know that if mu is equal to 3.4 centimeter is false, it means automatically that mu is not equal to 3.4 centimeter. What is new in it? Why unnecessarily we are adding another hypothesis and making the matter complicated? There is no sense in it. But it is wrong to think so. There is a sense in it. If the null hypothesis H naught that mu equal to 3.4 centimeter is rejected, then alternative hypothesis H1 mu not equal to 3.4 centimeter, this would not happen always. Suppose that theta is the parameter. Parameter means measure of some characteristic of the population. And suppose that theta naught is some assigned value of it. So null hypothesis that theta equal to theta naught, alternative hypothesis theta not equal to theta naught, this would not always happen. Alternative hypothesis would always not be like theta not equal to theta naught. I would give you some examples in this regard. Suppose there is some company manufacturing and selling some product. Suppose that the average quarterly sale is of say rupees 2.56 crore. Now for enhancing the sale, suppose the company start an extensive advertisement campaign for some period. Now it would be the interest of the company to know whether this advertisement campaign had some positive effect on the sale of that product or not. In other words, the manufacturing company would be interested in knowing whether there has been increase in the sale of its product after this advertisement campaign. So for this, it will conduct one survey, it will take one sample, and it will test a hypothesis. Now here, suppose that mu is the average quarterly sale of that product, mu. So the company would frame its null hypothesis as mu equal to 2.56. Now, what would be the alternative hypothesis in this case? Should it be that mu is not equal to 2.56 crore? No. Here, if we take this alternative hypothesis that mu is not equal to 2.56 crore, that is, the average quarterly sale is not equal to 2.56, then it would be wrong. Why? Because when we say that mu is not equal to 2.56 crore, it consists of two cases. There may be two possibilities. Mu would be either more than 2.56 crore or mu would be less than 2.56 crore. So not equal to means either greater than 2.56 crore or less than 2.56 crore. Now you see, the advertisement campaign was there for enhancing the sale of the product. Can anyone think that after the advertisement campaign, the sale of the product will go down? Certainly not. It would be a funny situation. Advertisement is for enhancing, for promoting the sale of the product. How can it lower down the sale? But if you are taking that mu is not equal to 2.56 crore, the average quarterly sale is not equal to 2.56 crore, then you are considering this case also that the average score is less than 2.56 crore, which is not reasonable to think. What would be the worst case in this situation? The average quarterly sale would remain as 2.56 crore. This would be the worst case. How can one imagine, how can one think that after advertisement the sale has gone down? So here we would not take our alternative hypothesis as mu not equal to 2.56 crore. Here our alternative hypothesis would be that mu is greater than 2.56 crore. So if the null hypothesis that mu equal to 2.56 crore is rejected, it means that the advertisement campaign has been effective and it has promoted the sale of that product. If the null hypothesis is accepted, null hypothesis, that is mu equal to 2.56 crore, it means that the advertisement campaign has no significant effect in promoting the sale of that product. So here is a situation where we are not taking alternative hypothesis as mu not equal to 2.56 crore. Alternative hypothesis is not equal to 10. Let me give you another example. Suppose a pharmaceutical company has launched a new drug, anti-hypertensive drug, and the company claims that this drug is very much effective in lowering the high blood pressure. Now it is your task to test the claim of that company. Whether this claim is true or this claim is false. Now what will you do? You will conduct one experiment. You will consider some patients suffering from high blood pressure. That is, you will take some hypertensive patients. Suppose that you have taken 20 such patients, hypertensive patients suffering from high blood pressure. Now you will measure the blood pressure of each of these 20 patients. You will find the average. Suppose the average blood pressure is denoted by mu1. Now we will start treat those patients on the basis of this new medicine, on the basis of this new drug. And after a sufficient period of time, suppose 2 weeks, 3 weeks or a month, you will again measure the blood pressure of those patients just to know whether their blood pressure has come down or not. Now suppose this time the average blood pressure is denoted by mu2. Now you will make your null hypothesis, that is H0, like this. H0, that mu1 equal to mu2. Average blood pressure before treatment is same as average blood pressure after treatment. This is your null hypothesis. In null hypothesis, we always take equality sign. Now the major role is in deciding the alternative hypothesis. What should be our alternative hypothesis here? Should we take our alternative hypothesis H1 as mu1 not equal to mu2? Again the same problem arises. mu1 not equal to mu2 means two possibilities. Either mu1 is greater than mu2, that is average blood pressure before treatment is greater than the average blood pressure after treatment. And the other possibility would be mu1 less than mu2. That is the average blood pressure before treatment is less than the average blood pressure after treatment. Now you think of the latter case. Average blood pressure before treatment is less than the average blood pressure after treatment, mu1 less than mu2. Is it possible? Is it not nonsense to say like this? How can we believe that a drug which is meant for lowering down the high blood pressure would increase the blood pressure? It won't happen. It doesn't seem realistic. The worst case would be that the drug would not be effective. Drug would not be effective means that mu1 equal to mu2. Average blood pressure before treatment is equal to the average blood pressure after treatment. But if this is rejected, null hypothesis, mu1 equal to mu2 is rejected, obviously what is accepted? mu1 greater than mu2. Average blood pressure before treatment is greater than average blood pressure after treatment. So in this case, our alternative hypothesis would be mu1 greater than mu2. So in this way, in different situations, we can have different types of alternative hypotheses. The framing of alternative hypothesis depends upon the situation. So there are two types of alternative hypotheses. I told you that in null hypothesis we always take equality sign. There are two types of alternative hypothesis. One type is of not equal to type. And the other type is of greater than or less than equal to 10. If the alternative hypothesis is not equal to type, then we call it two-tailed test. And if the alternative hypothesis is either greater than or less than type, then we call it one-tailed test. So our test would be either two-tail or one-tail. How can we know whether the test is two-tail or one-tail? It can be known from the alternative hypothesis. If in the alternative hypothesis there is inequality sign, not equal to, it is two-tailed test. But if in the alternative hypothesis there is either greater than or less than sign, then it is called one-tail test. So two-tail and one-tail test can be known from the alternative hypothesis. So whenever we test a hypothesis in the beginning, before applying the test, because we are not knowing whether our null hypothesis is going to be accepted or going to be rejected. So in the beginning, we would frame two hypotheses. Null hypothesis, which we would test, and alternative hypothesis, which we would accept if the null hypothesis is rejected. Now further, we will discuss in the next meeting. Wait for that. Thank you.